All right, this is your first video of today, and we're going to be talking about discrete and continuous random variables. So just a review of what a discrete random variable is. Discrete means countable, when all possible outcomes can be listed, like rolling a dice. Right? You can list the possible outcomes, 1, 2, 3, 4, 5, 6. That is a discrete random variable. Continuous random variables are random variables that can take on any values in an interval. Like your height is a continuous random variable. GPA is a continuous random variable. So let's look at our example today on your worksheet. Now, just a reminder, you can stop and pause this video at any time. I might be talking fast, but you can pause it, you can slow it down. Just whatever you do, make sure you take the time to fill in the notes, even if you don't understand everything. All right, so first we're going to count up the number of children in a family. So this is a sample from last year of siblings in a class, and you can see out of 30 students, X represents the number of children for each family. This is including all stepbrothers, stepsisters, half-brothers, and half-sisters. So this is a discrete random variable. It is a countable number, maximum being 8 children. So this is a valid probability model because all the probabilities add up to 1, and they're listed between 0 and 1, 3 out of 30, 7 out of 30, 9 out of 30. Question 2 asks if 5.716 is a possible value for X. Is it possible to have 5.7167 children in one family? No. This is a discrete random variable. It is going to be listed as a whole number, a countable number. If I wanted to make a histogram, going back to chapter 1, making a histogram for this, I list the probability on the y-axis, and then my possible outcome that X can take, it goes on the x-axis. X-axis represents the number of children. Okay, so notice my y-axis is now listed as probability. I would say that this is slightly skewed to the right with a single peak at 3, describing shape. Where's the tail going? This has a tail to the right side. That's why we say skewed right, or skewed to the upper numbers. Now we're going to describe what this probability statement means in question 4. The probability that X, your random variable X, that is the number of children in a family, is greater than or equal to 3. The probability that a randomly selected student has 3 or more children in their family, well, I go back up and I add them up. X being greater than or equal to 3, I add up these probabilities. If I scroll back up here, I'm going to add up these probabilities right here. Greater than or equal to 3 is just adding up these amounts from 3 to 8. I add them up and I get 20 out of 30 students. Describe in words what P of X greater than 3 means. Well, greater than 3, not equal to 3, is the probability that a randomly selected student has more than 3 children in their family. Not equal to, it's not 3 or more, it's just more than 3. Notice it's a big difference. Now it's only 11 out of 30. The difference is we're not including 3 in this statement. And paying attention to these details is going to be really important. Now we're being asked to find the average number of children in each family. Oh, sorry, the average of the X values. We're not there yet. We're not to expected value yet. So I have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Is a total of 36. 36 divided by 8 is 4.5. But this isn't actually the average because the frequencies are different. So no, 3 is going to have a larger impact on the mean than 7 because it occurs the most. Go back up here to our shape. Each one of these X values has a different peak, a different height on the histogram. So I have to calculate the expected value and that got cut off, expected value differently. I have to think about the probabilities when I'm calculating the expected value. So look at this formula here. This was in section 6.1. You take each x value and multiply it times its probability. To find the mean, to find the expected value, I will take 1 times 3 over 30. That's its probability. Plus 2, the next outcome is 2 children in a family. There were 7 out of 30. Plus 3, I take each outcome and I multiply it times its probability that it happens. And then I add those all up and I see that the actual expected value is 3.3 children per family. Now, when you are looking at expected value, you're going to want to keep that decimal. That decimal is telling us that it's somewhere between 3 and 4. Not speaking to the shape. Remember how we said this was skewed to the right? This 3.3 expected value for x is telling us that it's not exactly 3. It's a little bit more than 3, meaning our shape isn't perfectly symmetrical. There is some skewness there. It's not perfectly centered on the peak. All right, so in summary, here's our important ideas. Make sure you know how to write up a probability distribution. We were working on this in chapter 5, right? How to represent our probability and make sure it adds up to 1. A discrete random variable takes on a fixed number of values with gaps between the values. It's not continuous. Make sure you know how to sketch a histogram and how to calculate the mean, also known as expected value. I want you to try to check your understanding. I'm going to ask that you pause the video here and work through these problems and then check your answers. So go ahead and pause the video and then I'll show you the answers in just a second. All right, what you're seeing now are the answers to your check your understanding. You need to make sure you calculate what is being asked in the problem and use context. All right, think about things in context. As I keep scrolling, you can check your answers. If you have any questions, please let me or Ms. Pouch know. All right, that is the end of the first video. Move on to the pink worksheet in your second video.